Thanks for coming. I'm actually giving two talks today. Up until a couple of days ago, I thought I was giving one, but then I discovered I was giving two. So I've been preparing both of these, and I just finished them all as we came into this. So you'll excuse if it's a little rushed. This first talk is about the role of testers, the role of QA in the DevOps world. And to get you a little bit more enthusiastic, I thought I'd throw in a free copy of BDD in Action. Does anyone not have a copy of BDD in Action? Lots of people, cool. All you have to do, I've come up with a totally arbitrary and unfair way of choosing someone. Just tweet something cool that you discover or learn in the talk, your aha moment if you like. Hashtag it with DevOps PL and shift left, and maybe tag Wakaleo as well, just so I can find them. And the one with the most retweets wins. I'll do the draw at the end of the talk. Okay, so I want to talk about DevOps, and I want to talk about testers, and I want to talk about the impact of the whole DevOps culture and the DevOps movement in the world of testing. Because what we see is that in this agile or post-agile environment, if you like, the change is not only constant, but the change is actually accelerating. It's going faster and faster. We've got technologies coming in that change every few weeks, every few months, that we have to keep track of. It becomes very hard to keep up with what's going on and to figure out how we can actually stay up to pace. And that's one of the biggest challenges for testers in this whole new way of working. How many people are testers or related to testing? Most people are. That's kind of unsurprising for this talk. That's good. So we're moving to an environment slowly in some organisations, more quickly in others. We're moving to a way of working where teams no longer work in silos. In the old days, there would be a QA team. There would be a separate department that does testing, and it would be sort of over the wall. The development team would finish something, throw it over the wall to QA, and they'd go away and test it for 6 weeks. And I still see this happening, particularly in UA testing in larger organisations. Is anyone still in that environment? Yeah? But this is funny because you say don't work in silos, but some teams, when they co-locate, they're sitting in the same room, they're sitting next to the developers and next to the BAs, but they're still working in silos because they're still waiting for the development to be completed before they start testing. And that's still kind of working in the siloed approach, just the silos are a little bit smaller. So we still have a lot of that we have to get over. In DevOps teams, in modern teams, the aim is not so much to find bugs, the aim is actually to prevent bugs from happening in the first place. Because there's nothing cheaper to maintain than code that is not written. The best way to prevent a bug the best way to get rid of a bug is not to have the bug in the first place. Sort of like smoking. Best way to stop smoking is not to start smoking. And this is what the idea of shift left is about. It's about moving earlier on in the process where QA folk can actually leverage what they know much earlier on. And if you can leverage what you know, your ability to inject quality at different points in the process earlier on, then you have a massive impact in the project. And that's where we get a lot more engagement. Teams, what we're trying to do is get teams to engage much, much earlier on, even at the requirements discovery space. Who here in your typical projects is involved in requirements discovery? requirements discovery in a few, yeah, half a dozen or so. Not massive, but a few. That's getting there. That's what we want to get to. We want testers actually being involved right at the start. So that's what behaviour-driven development promotes. That's what we try and do. That's what a lot of the teams that I work with are all about doing. We're trying to get testers right at the start of the process. And another thing we need to do is to master automation. And when I say master automation, I mean master automation. Know it really, really well. So automation is actually non-trivial. It's not scripting. It's actually similar to production code. And there are no quick and easy wins. It's something you do have to master. And then it gets the fun bit. Who here can test in production? Who here is officially allowed in their job description to play with production? A few? Yeah. It's more interesting when you ask it in a room of developers. But actually monitoring in production, running acceptance tests in production, doing what we call semantic monitoring or continual testing, that's where we're going. That's where we're going with where if you can deploy your application 100 times a day, you don't have time to run manual tests in production. It's got to be automated. You don't have time for smoke tests even. You've got to have automation under control. So what can you do to keep up to speed? It's always a bit of a challenge. This stuff is moving very, very fast, and it's always a bit of a challenge to know how to keep up with the pace. And why we try to do this? What is DevOps? So there's a study done by Puppet that they do every year, and it comes up with some interesting numbers. One of them is that high-performing teams who do DevOps, because in a survey on DevOps, by definition, a team that's high-performing is one that does DevOps. So it's a little bit of a biased sample space, but still, high-performing teams basically between the time they start work on a feature and the time it gets into production, it's 440 times faster. That's quite a lot, isn't it? It's funny because last year it was about 1,200 times faster than low-performing teams. Good question. It's high-performing compared to low-performing. That's the way they measure it, because it's in the middle as well. But that number's actually interesting because it's last year, like I said, the difference between a low-performing team and a high-performing team was 1,200. Now it's 400. So low-performing teams are actually increasing, or there's a middle range. Maybe low-performing teams are still really low-performing, but there are less of them. I don't know. But in any case, the pack is reducing. People are getting better at this stuff. There are teams who are deploying really, really quickly. Also things like how often do you have to roll back once you deploy in production? If you're deploying 440 times faster than your competitors, if you're deploying many, many times a day, if something goes wrong, you want to be able to know about it very quickly and redeploy very quickly, and even better, you want to not have broken it in the first place. And what we do find is high-performing teams have 5 times less chance of breaking something when they go into production. And if something does break in production, they're way, way faster at fixing it, 96 times faster. So that's where the DevOps infrastructure side of things comes into play, where you can actually deploy really, really quickly if something goes wrong. But the trick is detecting if it goes wrong. Because at that speed, you need to be able to have an idea whether something worked or not really, really quickly. Because speed's all very well, but speed won't help you if you're deploying rubbish. You'll just deploy rubbish faster, yeah? It's one thing a lot of the DevOps documentation and products and promotion that tends to neglect. It's all about the tooling, it's all about the infrastructure, it's all about the virtualization and how you can build an infrastructure to deploy things 1,000 times a day. If you're not checking that what you're deploying is not rubbish, you'll just be deploying rubbish 1,000 times faster. And you can deploy something that works, but if it doesn't do the right job, you're still kind of deploying rubbish. The alignment factor is more important than deploying something that actually doesn't break or doesn't explode. Does it actually do what the customer wants? Does it actually deliver value? Can you prove that it delivers value? How do you know that it delivers value? It's always an interesting difference between often what the customer asks for, what the customer wants, and what the customer actually needs. They're not exactly the same thing. And one of the challenges that we face is figuring out exactly what the customer actually needs as opposed to what they're asking for, and making them line up. And that's where we'll see the role of the tester is really, really important. So what we're kind of after, we need speed. We need to be able to deploy quickly. That's infrastructure, but it's also the ability to go from code to something that's ready to deploy really, really quickly. We don't want a 6-month or a 6-week period of manual testing. We don't want automated tests that take 6 hours to run either. But we also need what we deploy, we need it to be relevant. It needs to actually match what we're trying to deliver and what the business is actually going to find useful. And incidentally, it's always nice if it works. That's a bit of a bonus feature. If it doesn't break. So we need it to be verified at different levels. We need to be verified at unit testing and all the levels up to actually verifying that it does the job, that it corresponds to what the customer asked for, what the customer needed, so the acceptance testing. So if we think about how this changes your traditional viewpoint of what testing is about, I like to think of it this way. Traditionally we say shift, we talk about shift left. Shift left is basically the idea of testers getting involved earlier, so more to the left of the process, which basically means testers getting involved as early as requirements discovery and requirements definition. But it's more than that, because it also means that testers have to get more savvy in the automation space, have to get much better at automation. And the problem is it's easy to do poor automation, unfortunately. It's not so easy to do good automation. It's doable, it's learnable, it's just a skill, but it's easy to get to a point where teams are doing fairly mediocre automation that creates more maintenance costs than the time it saves in manual testing. Does anyone feel that have worked in teams where they've had that experience? Where you're all really, really good at automation? It's a funny thing because often teams don't really realize it until they see other teams which are really, really good at automation do it, and they say, oh, could you show us how to do that? That looks really cool. How come you can write 10 tests 5 times faster than we can? It's not actually that to do with their raw ability, it's just the way they organise and structure the tests and the discipline they apply. So there's nothing magic or 10 times developer-y. It's not that sort of thing. It's more about the approach and the discipline and the skill sets you use. And I'll talk a little bit about that, but it's not really the core topic of this talk. I've done other talks on automation, which I probably are available on DevOps, on the DevOps talks at somewhere. I do a lot of talks. But I do want to emphasize that the automation side is really, really important. That is a skill set you need to master. And if you don't master it, then you pair up with developers and get them to show you how to master it. And on the flip side of that, if you can master the automation and not have automation take all your time, not have to spend a lot of time fixing broken automated tests, then that frees you up for doing testing that actually requires brain power, exploratory testing, the testing where you actually can get a lot more leverage and make a lot more impact. Because testing the login screen for the 100th time isn't really going to add that much value. But doing some exploratory testing around authentication and sessions and cookies and penetration testing, that's more interesting. And then we do what we call stretch right, which is going to production. Can you run your acceptance tests? Can you run your automated acceptance tests in production? I'll tell you some stories about some places that do. So the first thing I want to talk about is this core shift left activity, which is requirements discovery. And I want to tell you a little story. This happened on a team I was working with in Sydney, Australia, some years ago, and it was for the New South Wales bus operators. Basically, the transports for New South Wales, it's a government service, and they run these bus operators. And the bus operators, who are private companies, they have to upload statistics each month to say how well they did. So, were the buses on time? Did people complain? Did they sell all the tickets they thought they would? Did they run all the buses they said they would, and so forth? And the requirement, the story that came through, or actually was an epic that came through on the backlog from the BA, said something like, well, the bus operators will upload an Excel spreadsheet to the system, and that'll get processed by a manager, the manager who looks after the bus operators. You with me so far? So Excel spreadsheet, system, manager. And 5 days before the end of the month, that Excel spreadsheet uploading mechanism gets blocked. And if the bus operators have to change anything, they have to go through this complex workflow with approvals and all sorts of complicated authorizations to get it deblocked so they can upload the changed version. That was very complicated. That was like 3 months of development work. It was quite a complicated integration piece. And so when we were going through the requirements, this tester, whose name was Salia, if I remember correctly, was asking some questions about the requirements and saying, okay, well, what happens if the format of the file is incorrect? What happens if the dates don't match? And then after a while she said, well, why does the system have to get blocked? What would happen if it wasn't blocked? What do we achieve by blocking it? And the answer was, well, the old system did it that way, and we're doing a migration of functionality. So because the old system did it that way, the new system has to do it that way. Has anyone heard that argument before? And so we sort of investigated. She asked, okay, well, why did the old system do it that way? Well, it turned out that in the old, which was an old mainframe system, that was the only way for the bus manager to actually know that the data had been changed. So we ditched a 3-month epic and replaced it with email notification and saved quite a bit of money. So this is just an example of how being involved earlier on in the process, you can get a lot more leverage than if you have to wait till the end of the process. When you're after the software's been delivered, you can basically say, does it work or does it not work, according to the specifications which are all written up earlier on. But you can't really say, well, what if we did it this way? Is that really the best solution? excuse me. And that is the leverage we can get if we start to do things earlier rather than later. So in a traditional approach, you'll have something like this. You'll have a story that will come into a sprint or be defined somewhere. It'll get developed, you get a test script, the testers will test it, it'll all be good, it'll go into production and everyone's happy. Yeah, what could possibly go wrong? So the problem is that when you test it, you find bugs, so there's rework, so that's inefficiency, that's a waste. You may have misinterpreted stuff, so there's misinterpretation, which can result in change requests. And more subtly, you can also have missed opportunities because the business is basically saying what they would like. Oftentimes, a business are actually presenting you with a solution, saying, would you like you to do this? They're not saying, we need to solve this problem. And in that sort of approach, you get this sort of mini waterfall where you're basically getting these requirements being handed down. It doesn't matter that they're called stories. There's still requirements being handed down, developed, tested, delivered. You don't get that feedback cycle where you can get more leverage. So it turns out that almost all defects in some cases are actually caused by ambiguous or incorrect requirements, up to 80% according to some studies. If you can catch them, if you can fix the requirements at the requirement stage rather than at the development stage, you imagine the massive savings you can make. So in a DevOps approach, this is basically what you might call behavior-driven development. We have a much more collaborative approach. We take a story, we get together, we have conversations about it. And out of those conversations, we come up with examples, we come up with rules and acceptance criteria, and above all, we come up with a shared understanding. And out of that shared understanding, then we can turn that shared understanding into what we call executable specifications. We can automate those executable specifications, they drive the development, and then we can do exploratory testing on top of that and deliver code with a much higher chance of actually doing what we expect it to do. And this involves collaboration at the requirements discovery level. And I like to see, we call this in BDD terms, we call it the three amigos, because there are three people or three roles that are very important. And there's actually more, can be more people than that, but it's three core roles. We've got basically the advocate, the person who's describing the requirements they need to build, the skeptic, the person who doesn't believe that they'll work, and the cross-examiner, the person who will tear them apart. Who do you think the testers are? The testers are really good at this. That's their job. The testers are really, really good at basically saying, okay, well, what if this? What if this? Have you thought of this? And so we try and do that before the code actually happens, rather than after the code gets built, and that makes a huge difference. So if you're interested in that, I'll be talking about more of the BDD approach in the talk that follows this one. I do want to touch on automation a little bit. Because basically, automation is something we can't really avoid. We need to be able to do it. But if you do it wrong, or if you don't do it well enough, it becomes really, it basically dominates all of your activity. It takes too much time. You end up overrunning the sprints because you can't automate fast enough. You end up writing automated tests after the stories have been delivered, and it becomes a big mess. So we don't want that. We want you to have a level of automation where you can actually basically automate all of the acceptance criteria that you want within the sprint. It's not that hard to do. Like I said, it's more about discipline and the way you approach things than any magical skills. But what we do find is that there are a lot of commercial vendors out there, most of the tools that they propose don't do all the magic stuff that they say they do. I haven't yet found a commercial tool that will give you the flexibility that you can get from just coding. But you need to code it well. And there are a few tricks to doing that. There are things like, well, the first rule of all is you need to treat your code as if it's production code. Your test code is basically production code. So it needs to be treated with the same amount of respect and the same amount of care. It needs to be refactored, needs to be maintained, needs to be kept clean and so forth. It needs to have the same design patterns, the same structure, the same discipline that you'd apply to production code. And on the flip side, if you're struggling to test an application because you've got an HTML page and there are no IDs or classes, if you've got a back-end system that has no APIs, so you can't access the data, so you have to inject data through the UI, if you've got an application which basically is test resistant, it will make writing nice tests a lot harder. And to do that, you need to engage with the developers to get them to actually make the code more testable. Now that can be as simple. I've seen testers writing web tests and the developer's like 2 meters behind them and the tester spending an hour trying to figure out an XPath expression to access an obscure element in a table, whereas they could turn around and ask the developer to put a CSS class in the web page. Simple things like that. And often the developers will say, no, we don't want to do that because that would be putting testy stuff in production, as if it's some sort of sacred thing, or you don't put dirty test code in production code. There's no problem with doing that. There's no problem with making your application testable. It makes it cheaper and easier to maintain for everyone. So we need to get to the point where applications are basically testable out of the box. And it's a lot easier to do if you do it early on. It's a massive pain if you start doing it later on, late in the project. Another thing that I see teams not do quite a bit is layers of abstraction. And I'll talk about this in the next talk a little bit as well, but oftentimes I'll say, who has seen a Cucumber scenario, examples of Cucumber where you have, given that I am on the login page and I enter Scott into the user name and I enter Tiger into the password and I click on the login button, then I should go to the home page. Anyone come across scripts like that? Yeah? That's a really rubbish way of testing because there's no abstraction at all. It's straight onto the UI. I'll talk more about that in the next talk, but basically a correct way of doing that, a better way of doing that would say, given I have authenticated or given the user has authenticated with correct credentials, and that's it, under the hood for the rest. You don't need to worry about what screen it is, what field it is, and so forth. That's not the level of detail that you would want at the level where you're describing what the test does. In anything you do, you can think of it in 3 layers. At the top, you've got why. Why are you doing it? Because I want to access my data, because I want to access my accounts. Because nobody ever wants to log in. Logging on is a pain. So given that I want to log on, it's not really very realistic. The real reason would be I want to access my data securely. So you've got the why at the top, then you've got the what. Why do I want to access my data, or what do I want to do with my data? I want to see my account balance. Then the how, I authenticate with valid credentials. I log on with valid credentials. So all it's why, what, how. Another thing that good test suites do, or good teams do, is they're very finicky about the way the test results are presented, the way the tests get reported. So if you've done anything, who's worked with WebDriver, Selenium? So if your test fails with a web element not found exception, how much does that tell you? Not much. It says, well, web element's not found. What if it told you client record not found? Maybe a bit better. Depending, maybe if you had a message that was actually specific to each screen, so you said in business terms what it was trying to do or what it couldn't do, that's going to make it a lot easier to troubleshoot when it goes wrong. Little things like that. You want to make the tests as communicative as possible. So you can think of this in terms of an acronym as well, FAST. So good tests are FASTs, and like GNU, fast tests are fast. So they're quick, they run quickly. If your test gives slow feedback, it's the longer your feedback, the slower it is. I mean, I've had actual real cases where test suite, the teams have said, okay, we're going to turn off those test suites because they slow us down and prevent us from deploying to production. This kind of defeats the purpose a little bit. They're actionable. So tests are actionable. You know what to do. You know that if a test fails, it's because a customer has not been found, or that a bank account has not been provisioned, or something like that. You know what to do about it. You don't just say web element not found. They're scalable, so you can actually increase the scope, you can ramp them up. And scalable is not just running lots of tests. It's not just having a big test suite, it's being able to add tests quickly as well. That means that any new test that you write is as easy to write as the first test. Oftentimes, as you add new tests, you struggle to add them into the existing test suite. And they're also trustworthy. They'll tell, when you see an error message, you'll know what that actually means. And the last section is called stretch right. So, production monitoring, running tests in production. Now there's a newspaper in the UK who have a policy of systematically publishing fake news every day. It's not the one you're thinking of. So it's actually the Guardian newspaper. The way they test their application is every day they publish little articles. And no one can see them because they've hooked it up so that it's only visible on the web pages and on search results internally to their network. But they're basically continuously publishing and pushing articles through their workflow because that's their main business goal. Doing that continually. Takes a few seconds to run a single test, but they're doing them over and over and over again. And that's what we call continuous testing. We're not just pinging the server to see if it's there. We're not just saying, is the database up? You're actually performing business tasks. You're performing business operations and seeing if your core business functionalities still do the jobs that they do. So they're acceptance tests, proper acceptance tests, but they run them in production. But to do that, there are a few things you need to take into account. You can't just run any random acceptance tests in production. You have to do things like cater for the fact that you don't want that data going into production. If you're doing web tests, there can be random failures. It's easy to get 90% success rate on web tests. It takes a bit more effort to get to 95% reliability. 99% you can do it if you muck around with the network configuration. That last 1% is really, really hard. So what they do at the Guardian is they actually do statistical testing. So they run the test so fast that if a test fails, in the next 10 seconds they'll have run it again. And if it keeps failing a few times, they'll consider it an actual failure. And I've seen that approach used in other places as well, when they have unreliable external factors that will mean that sometimes the test will genuinely fail. But they want to know, is it just a sporadic failure or is it actually a real one? So that is a really important factor as well. Another thing that organisations do is chaos monkeys. Netflix in particular, basically they'll take out servers randomly and see if the system can cope. So it's more an infrastructure. The idea of chaos monkeys is more an infrastructure thing. But you can do that for acceptance testing as well. You do semi-randomized testing. Don't just send always the same data. You send slight variations on data. Each time your tests run with a slight variation, so that effectively you're doing randomized testing, and effectively you're injecting uncertainty into the tests to increase the coverage, the functional coverage of what it's actually doing. Yes? That's a really good question. How do randomized tests correspond to repeatable tests? Basically, in practice, you'll have some core scenarios which are repeatable, but the tests are repeatable in the flow. They'll do the same flow, but then they'll say, okay, given I open an account with a valid name, and then the valid name will be a random valid name from a known set of acceptable name patterns. So the high-level flow will be the same, but the details will be different. So they're not actually repeatable tests, but you can repeat them if you want to run it manually. You could tweak it to do a hard-coded value, because you could see what values were actually used when you failed. Yeah, and you'd probably tag them slightly differently or have a configuration so that you could run your core tests in one batch and then have a set of repeatable randomized, or more chaotic randomized, almost exploratory tests as a separate set. So on exploratory testing, so there in some parts of the testing community, some debate about whether you should say test or check. Is anyone familiar with that debate? Yeah? I'm not sure it really matters. It's sort of like the difference between these two colours. Now, I've just totally screwed up your knowledge of what scarlet is and what crimson is, by the way. You'll never be able to recognise them anymore. But really, these are both red for most people. If you're not an interior designer, it's two shades of red. So lighter red and darker red, maybe. Test and check. In the context, I don't think it matters. But what is important is the idea that there are types of tests, exploratory tests in particular, that require your intelligence and that are beyond just your automated tests. So your automated tests do a certain level of testing, but you need to be able to go beyond that and test do exploratory tests or penetration tests, security tests, whatever other sort of testing you need to do, context-driven testing, what other sort of tests you need to do to have that confidence level in the application. You can't rely on automated tests for everything. Automated tests give you your baseline. So the automated tests should give you a level of maturity, should give you a level of stability so that you can then go on to more intelligence-based testing. And what I see in some teams is you get the opposite. You get people basically spending all their time maintaining the automated tests, because the automated tests have become very, very hard to maintain and brittle and unreliable. So I've seen some cases where basically 1 day a week, the test team will have their entire job will be to go through the broken automated tests and try and reproduce them manually. I've seen other teams where it's actually every morning they'll do that. So basically half of their time is spent on maintaining automated tests. And that's a massive overhead. I had another team where I heard a colleague of mine worked with these guys, and they ran their automated tests, but they came quite unreliable because they weren't writing them well. And so they hired a whole lot of manual testers to come in and every day rerun the automated tests that failed manually. So you don't want that. You want your automated test to serve the team so that the team can do better testing beyond that and not the other way around. Now I work with a lot of teams trying to introduce these sort of practices, so behaviour-driven development and test automation and so forth. And I see a lot of similarities in the way the teams progress through what we could call levels of maturity. Often they'll start off with a siloed mentality, if not a physically siloed locations. And when they start to do Agile or Scrum, they will start to be co-located, but to get really out of a silo mentality, we have to actually have testers involved much earlier on. And the idea is to reduce that bottleneck that you get at the end of whatever phase you're doing, which is dedicated to manual testing. Or has anyone been in teams where you deliver a story in one sprint and then you test it in the following sprint? No? Yes. Obviously that's not ideal, because if you're delivering it but it still needs testing, you're not really delivering it. And when the testers find bugs, they tell the developers to go and fix this, and the developers say, I don't want to fix this, I'm working on this cool new stuff. No, you've got to stop that and go and fix it. So it slows down the developers. So it introduces waste into the process. That's obviously not ideal. So we want to reduce those bottlenecks by getting the developers and testers working much closer together. And we do that by trying to get them more engaged in from the early stages onwards. So that cross-examiner role is very important for this. Improving collaboration and trying to prevent defects right from the word go. The interesting thing is this doesn't require automation, and this has pretty significant benefits just if you do this engaged phase. You get some massive benefits merely from the fact that you're improving everyone's understanding of what needs to be done right from the word go. Then you get to automation, so what we call the mechanized stage. So often people actually start with the automation, but if you automate before you engage, the problem is you run the risk of automating the wrong thing. So you automate after you engage, and then your automation becomes much more precise. It also means that you're automating and collaborating with the developers, so your automation will be more efficient. So engage, then automate. And once you master the automation, you can start to experiment. You can get to the point where you can deliver faster, so you can start to say, well, what if we did this? What if we did this? How about we try this? And then you can start to actually exceed the expectations of the customer. And going even further, you get to the point where you're learning. You get the customer to experiment. Get the customer to say, well, what if we did this? Or I think if we tried it this way, then we get these benefits. So you get into what we call hypothesis-driven development. So that's what I wanted to cover today. If you do want to know more, there's a newsletter here where I do publish articles every couple of weeks or two on these sort of topics. There's also a book that someone's going to win shortly. But before I do a draw, are there any questions? Yes? Mutation testing. So mutation testing is sort of like the chaos monkey testing, so the randomized testing. As in, should it be at the acceptance testing level, or should it be internal? Is that the question? It's fairly high up. It's once you master acceptance testing, then you can start to think about variations. Any other questions? Yes. So the question is how you cut down on the time taken to maintain the tests. Basically, by the same way as you cut down the time taken to maintain production code. You use the same sort of engineering principles, object-oriented programming, layers of abstraction, solid principles, clean coding, all of those principles, you can apply them to automated code as well. And there are a number of patterns. I mean, page objects is a very basic one, but beyond page objects, there are patterns like the screenplay pattern, which make it much easier to have reusable components that don't have to be updated. So once you have a task component, it only needs to be changed if the application changes, and in a particular part of the application changes. So there are techniques like that which make it easier to limit the impact of maintaining those tests. Cool. If there aren't any questions, then I will see who has tweeted. Anyone tweeted? Anyone want a book? Should I give you 5 more minutes to tweet something? I love the cap. Okay, well, that's a winner. Right. Let's just let the network go through. Okay, my telephone's not cooperating. Okay, I can't pronounce the name, Limestream. You've won a book.